Thank you for purchasing the Creating Electricity with Magnets kit. In this video, I will help you dive into the fascinating world of atoms and electrons and experience the thrill of creating electrical currents in copper wires, just like the legendary scientist Michael Faraday. So let's get started. To help you understand magnets, the kit includes a compass. A compass is a small magnet on a low-friction pivot that detects Earth's magnetic field and points to magnetic north. It can be affected by nearby metallic or electronic objects, so to avoid false readings, keep it away from metals, magnets, and electronic devices. Enjoy using the compass and take a moment to appreciate the significance of what this simple experiment demonstrates. The kit contains all the components needed to replicate one of the most important experiments by the legendary scientist Michael Faraday. You might know magnets as magical pieces of metal that repel and attract, and that copper is a good conductor of electricity. Faraday aimed to transfer the force from a magnet into a copper wire. To do this, he needed an instrument to detect the force. He realized that placing a pointer on a magnet inside a small coil of wire would act as a detector if any force appeared in the coil. The kit includes such a detector. Faraday connected the detector's wires to a larger coil, placed a magnet inside this coil, and waited for the pointer to move. Initially, nothing happened. Try it yourself. If the magnet is stationary in the coil, nothing happens. But when Faraday moved the magnet in and out of the coil, the pointer moved back and forth. Try this yourself and consider what it means. You have just created electricity. Now, consider that the universe and everything in it is made of atoms. An atom has a nucleus with protons, neutrons, and electrons spinning around it. When the magnet moves inside the coil, the protons and neutrons remain unaffected, but the electrons get a tickle. They sense the force from the magnet and pass this tickle to the electrons in neighboring atoms, creating a wave known as electricity. We can only create electricity by transferring kinetic energy from our arm movement. This demonstrates the principle that energy cannot be created or destroyed, only transformed from one form to another, as discovered by Albert Einstein in 1905. Take a moment. I hope this sparks your curiosity and encourages you to further consider the significance of what this simple experiment demonstrates. Now that we know how to create electricity, what can we do with that knowledge? Moving a magnet in and out of a copper coil is quite awkward, so let's place a coil of copper wire on a spindle and use special engineering to connect the two ends to a detector. Then place a magnet on each side of the coil. When the spindle is stationary, no electricity is created. But if we use a propeller to spin the spindle, this energy will tickle the electrons in the copper wire and create electricity. Try this yourself. When you spin the propeller, the pointer on the detector will move. Spin the propeller in the other direction, and you'll see the pointer move in the opposite direction, showing that electrons can move both ways. Now, consider other ways to spin the propeller. Hydroelectric plants use falling water to spin a propeller. Coal, gas, and nuclear power plants boil water to create steam and spin propellers. Wind turbines use wind to rotate a propeller. In all these instances, the principle discovered by Michael Faraday remains at the heart. To create electricity, you need magnets and a copper coil of wire. Now, take a moment to further consider the significance of what this simple experiment demonstrates. Now, let's have some fun with our final experiment. The kit includes ring magnets and a pole. Normally, the ring magnets are placed together on the pole and act as a single magnet. Now, take one magnet off the pole and turn it over so it repels the others. You'll see this magnet hover above the others. This type of levitation is used in Japan to create trains that travel at much faster speeds by eliminating friction, which slows things down. Take a moment to explore and understand all the experiments in this kit. Remember, we are hoping to spark your curiosity. Bye for now.